Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this general science physics, we have completed electricity topic and recently started magnets and magnetism also. If you want previous, you can watch in the playlist. Okay, let us start the session. Let me check up to which we have completed in this magnet, bar magnet and its properties. After that, the important terms, and I have compared these important terms with electrical for better understanding. Okay, and those units are very important. After that, we have completed Faraday's laws of electromagnetic induction, first law and second law, and motoring principle. Now we are going to discuss the two important rules, Fleming's left hand rule and Fleming's right hand rule. Okay, so very important this one. Fleming left hand rule. Left hand rule. Fleming's right hand rule. Right hand rule. I want to say one important thing, guys. So many students just open the session and just skipping. Okay, if you open and skipping, you may not get anything. Correct? For example, in front of you, if you have biryani, if you just see the biryani, you may not get. Correct? Whenever you eat, then only you enjoy that one. Here also, whenever you complete the full session, at least one or two sessions completely, then only you can enjoy the class. Okay, getting or not? Just opening and skipping means just waste of your time. You may not get anything. Okay, so try to complete at least 2 to 3 sessions. If you don't like, you can skip. Okay, so Fleming's left hand rule and right hand rule. So many students having the confusion with the Fleming's left hand rule and right hand. It is very simple, guys. Fleming's left hand rule, Fleming's right hand rule. Here one important thing is that this Fleming's left hand rule, right hand rule, in both cases the indication of fingers same. Once again, if it is a left hand rule or right hand rule, the indication of fingers are same. That means if you stretch the three fingers of your left hand and right hand like this, that means all the three fingers are mutually perpendicular to each other. All the three fingers are mutually perpendicular to each other. What are those three fingers? Thumb, forefinger, middle finger. Okay, thumb, forefinger, middle finger. If you stretch these three fingers mutually perpendicular to each other, in this case, the forefinger gives direction of magnetic field. Okay, and middle finger gives the direction of EMF or current. Middle finger gives the direction of EMF or current. Thumb gives motion or force. Thumb gives motion or force. Okay, so note down that point. If we stretch three fingers, what are those three fingers? Forefinger, middle finger, thumb. If you stretch three fingers mutually perpendicular to each other, mutually perpendicular to each other, then in case of left hand rule, forefinger finger gives the direction of F for field. Field in the sense magnetic field. Okay. Forefinger gives the direction of magnetic field. And second one, middle finger. Remember like this, middle finger. I is the domination. I is the direction of current. Direction of current or EMF. EMF means electromotive force. And the third one, thumb. Thumb gives the direction of force or motion. Okay, in which direction it is moving. In the left hand rule, this is left hand rule. In case of right hand rule, Fleming's right hand rule. What I said, the indication of fingers are same. So here also same. Forefinger gives direction of magnetic field. Middle finger gives direction of current or EMF. I for I. And thumb gives direction of force or motion. Force or motion. Okay. So all of you getting Fleming's left hand rule, right hand rule. In any rule, all the indication of three fingers same. There is nothing different. There is nothing different. Okay. If there is no difference, then why we require two rules? Why? Because if you observe carefully your three fingers of both hands, okay, so direction of field is same na, outward, always towards to any one person. Thumb is upwards, both same. But what about the direction of current or EMF? Here it is in this side, but it is in this side. That is opposite sides na. The middle finger are showing opposite sides. Based upon this reversal in the direction, based upon the reversal of direction of this middle finger, the application of these two rules are different. So applications are different. What are the applications? That means where we are using left hand rule, where we are using right hand rule. Those applications only different. Okay. So in case of left hand rule is used in motors. Fleming's left hand rule is used in motors. Motors to find direction of EMF, direction of motion or force. Okay, motor output is nothing but force or motion na. So to find out the direction of motion or force, we use the Fleming's left hand rule. In the same way, Fleming's right hand rule. Fleming's right hand rule. Right hand rule is used in generators. Used in generators to find direction of current. Direction of current or EMF. All of you getting the difference in the left hand rule and right hand rule? If you stretch all the three fingers mutually perpendicular to each other, whatever it may be, left hand rule or right hand rule, forefinger gives the direction of F for field, magnetic field. Middle finger gives the direction of current or EMF. Thumb gives the direction of force or motion. Okay. Left hand rule used in motors, right hand rule used in the generator. Okay. There is a small trick is there to remember this one. In case of generator, if you observe, this is just a trick only. Generator. Here we have the two R's. Two R's are there. R is domination. R for right hand rule. R for right hand rule. So in generator, we use the right hand rule. We use the right hand rule. In case of motor, just one R only, less R. Okay. less R. So that means it will be a left hand. Okay, that is a small trick to remember. So more R's are there, nothing but right hand rule is the domination. Fleming's right hand rule is used in the generator. Motor, left hand rule. Okay, all of you got it? It's a very important thing, left hand and right hand rule and their indications. Okay, so after this we have to take magnetic materials. Magnetic materials. Okay, so the magnetic materials are divided into three types. Magnetic materials classification. Okay, so here magnetic materials are classified into three types. One is diamagnetic. One is a diamagnetic. Second one is paramagnetic. Third one is ferromagnetic. Okay, it is same like insulator. In the electrical, we have the insulator. Here, semiconductor. Here, conductor, like that. Okay, similar properties. Okay, so here in the diamagnetic material, which are magnetized weakly, the materials which are magnetized weakly, in the opposite direction of magnetic field. Direction is opposite here. In the opposite direction of magnetic field. Okay, here these paramagnetic, these are also weakly magnetized. Sorry, which are magnetized weakly or weakly magnetized. It is better to write weakly magnetized. Weakly magnetized. Okay, here these are also weakly magnetized, but opposite direction, sorry, same direction to the magnetic field. Same direction to the magnetic field, but same direction to magnetic field. Okay, and coming to the ferromagnetic, these are strongly magnetized in the same direction of magnetic field. Okay, here weakly magnetized in opposite direction. Opposite direction means generally magnet attract iron particle, but opposite direction means it has some repel. So it has some repel. Some repulsive force, some repel from iron particle after magnetization. Okay, so diamagnetic materials are weakly magnetized. Para also weakly. Ferromagnetic materials strongly magnetized. But the direction here diamagnetic. If it is the magnetic field direction, here these are magnetized opposite. Here it is a magnetic field direction. The paramagnetic materials also same direction. If it is a magnetic field direction, ferromagnetic materials also same direction. Okay, same direction. Now coming to another very important thing, permeability of this dia-para-ferro. What is this permeability? So note down one important term, permeability. I have already given this word denoted with the letter mu. Permeability is nothing but, as the name itself, it is the ability to permit the flux. It is the ability to permit. Permit means allows. To permit the magnetic flux. Okay. If we have higher ability, higher magnetic flux. If it allows higher magnetic flux, then you can say that is the high permeability. High permeability. Generally, mu is equal to mu naught into mu r. Here, mu is just permeability or permeability of material. Permeability of material or permeability of medium. The units are Henry per meter. Very important. Henry per meter. And mu naught is said to be absolute permeability. Absolute permeability. All these are very important for exams. Absolute permeability or permeability of free space. They will ask the units. Permeability of free space. Okay, these units are also Henry per meter. Henry per meter. And now mu r is equal to mu by mu naught. Here also Henry per meter. Here also Henry per meter. So both will be cancelled out. So relative permeability having no units. Very important. Relative permeability having no units. Okay, having no units. Now coming to this permeability values in the dia. Permeability values. Here weakly magnetized means it allows very little amount of the flux only. It allows very less means, that means it permits very less means permeability value is less, that is less than 1. And in case of para, it is also weakly magnetized but more than dia. So permeability is just greater than 1. Here ferromagnetic materials, the permeability is, they are strongly magnetized means they lose very high amount of flux through it. So permeability is very much greater than 1. Very much greater than 1. So these permeability values are very important. Okay. And if they are asking susceptibility means it gives the amount of magnetization. Here weakly magnetized na, so its value is less. And in which direction? Opposite direction. So small, less and negative, or small and negative. Okay, less or small and negative. Here same direction but weakly. So small and same direction means positive. Here same direction and strongly na, so large and positive. Large and positive. Okay, so these are the very important points belongs to dia, para and ferro. Okay, now coming to examples. In the exams, the examples are very important. But unfortunately we have not tested all these materials in the laboratories to understand the properties. That any particular material is a dia, para, ferro, like that. So that's why we have to make a small tricks to remember only. Okay, there is no other option. Ferromagnetic materials are strongly attracted by magnets. Okay, these are strongly attracted by magnet. These are generally strongly magnetized, means strongly attracted by magnets. We know very well iron is there now. Iron is strongly attracted by magnet. Example, just remember as the nickel. Okay, just remember as nickel. Nickel is the ferromagnetic. N for nickel and I for iron. I for iron. N for nickel, I for iron, and C for cobalt. Okay, so nickel, iron, cobalt, and their alloys belongs to ferromagnetic material. Simply you can remember like this. Nickel, iron, cobalt belong and their alloys belongs to ferromagnetic. Alloys means steel. Steel is belongs to uh, steel is the mixture of iron plus carbon. So it is a alloy of iron. Okay, and alnico, and also tungsten. So all these are very important examples in the exam point of view. Okay, coming to para. Para, just like remember like miums, all miums, aluminium, platinum, chromium. These are belongs to para. Okay, and M for manganese, also belongs to para. And in case of air, oxygen is belongs to paramagnetic material. Very important question. Now coming to dia. First three high conductivity materials. High conductivity materials like silver, copper, gold. So these three you can remember like that. Top three electrical conductors. Top three electrical conductors. Conductors belongs to dia. After that, we have to remember like alphabetic order. Antimony. These are repeated ones only. Antimony. Bismuth. B for bismuth. And then hydrogen in the gas is very important. Hydrogen, mercury, quartz, zinc. Okay, so these are the very important diamagnetic. Okay, antimony, bismuth, hydrogen, mercury, quartz, zinc. These are the very important examples of diamagnetic, paramagnetic, and ferromagnetic. Okay. In the next session, we will go with another topic. Okay. So this magnets and magnetism almost completed. If any topic is not covered, that will be covered in MCQ sessions. Okay. Fleming's left hand rule and right hand rule. After that, magnetic materials, dia, para, ferro, and their examples. Okay. We'll discuss the next session, that is work, power, energy. Very important topic. Okay. And students, so many students just watching and not subscribing. Please subscribe to get the notification, and also not sharing. Please share to your friends. Whenever more number of students are watching, then I will get interest to take the more sessions. Okay. Otherwise, the uploading of sessions may be somewhat of slow. Okay, what I feel whenever my classes are not useful for students, I feel that there is no use of the sessions, so that maybe demotivate me. Okay, So please try to share to your friends and also click like option if you like my classes. Okay, and all of you try to join in the Telegram group also. I have given the Telegram link in the description box. From that you can join into the Telegram. Okay, thank you so much guys.